Hello, Chris and Jamar here for Project 5. This week's problem was the locker puzzle. It goes like this. There are 100 closed lockers and 100 students. The first student walks up to the first locker, opens it, and proceeds to open all of the lockers. Then the second student walks up to the second locker and closes it. The second student proceeds to close the fourth locker, the sixth locker, and so on, incrementing by 2. The third student walks up to the third locker, closes it, then opens the sixth locker, then closes the ninth locker, and so on, incrementing by 3, and closing the locker if it's open, or opening it if it's closed. Every student repeats this algorithm, walking up to lockers, changing their open and closed status, until finally the 100th student walks up to the 100th locker and opens it or closes it if it was open. Our task was to find which lockers were open at the end of this process. So for the design of this program, we took a top-down approach. We wrote the main method first, calling other methods with method stubs written underneath. This saved time and made testing and debugging easier. We split this problem into 3 parts in the main method. For the first part, we declared the constants for the number of students and number of lockers, and initialized a Boolean array with 100 lockers that are either true, open, or false, closed. By default, they all start closed. For the second part, we created and called a method to simulate the students opening and closing the lockers. This method looped through the students and looped through the lockers for each student, changing the array values from true to false and vice versa. For the final part, we called a method that would loop through the lockers in the array and print if the locker was open or closed. Turns out that the only open lockers were the perfect squares, 1, 4, 9, 16, so on until 100. Jomari will now go over the code and testing.
Okay, so for the main method, first part of the main method was declaring the locker array. And for this, we had a 101 element array because arrays usually begin, or not usually, they always begin with 0. And so our code, instead of shifting everything by 1 at the end, we decided to increase our array count by 1. And so for the other methods, the open logger method, it was a nested loop that went through every single locker number, and within that loop it would count by whatever student was opening that locker, and it would, since we were using Boolean values, it would the locker, we would hold the opposite value of whatever it had. So since all the lockers were began closed, if we if 1 was ran through this, C would equal 1, and since locker number 1 is closed or false, then that would mean locker number 1 is true, and that would just repeat until it hit locker length minus 1, which equals 100. That would continue until it equals 100. And then for the last part, the last method, it's just a loop that prints out the open lockers. So if the locker is equal, if the locker is true or open, then it would print out. So we can just run this again and show there are the answers. And yeah.